going to start off today by learning how to draw Lewis dot structures for different types of compounds. The first thing that we need to do is to decide if the compound is ionic or covalent. So look at the first element. The first element is a non-metal. Second element, bromine, is a non-metal. So when two nonmetals come together, they form a covalent compound. Now next, I need to go ahead and I decide what my central atom is. So the central atom is going to be the one that forms the most bonds, so you can draw the Lewis dot structure of each element and determine the number of bonds it'll form. Or another general rule would be the one that you have the least amount of is going to be your central atom, but that's not always true. But the more you do it, the more you'll get the hang of it. So I have 1 phosphorus and 3 bromine, so I'm going to go ahead, and phosphorus is going to be in the middle. My next step is determining how many total valence electrons I have in the entire compound. So phosphorus has 5 valence electrons, plus we have 3 bromines, and each bromine has 7 valence electrons. So 3 times 7 is 21, plus 5 is 26 valence electrons. So at the end, this compound should have 26 valence electrons. Now we'll go ahead and start bonding these atoms together. So the first thing we're going to do is we're going to go ahead and create a single bond connecting each atom. After we've bonded each atom, I want to go ahead and I want to complete the octet for each atom. And the octet means I want 8 valence electrons around it. So most atoms want 8 electrons. Each bond counts for 2. So right now, bromine has 2 in the bond, 3, 4, 5, 6, 7, 8. The next bromine is the same, 2, 4, 6, 8, and the third one is the same as well. Phosphorus has 2 in each bond connected to it, so it has 2, 4, 6 in the bonds, and then I'm going to count 7, 8. Now once we went ahead and bonded everybody and we went ahead and we made sure that the octet was filled, we want to go back and we want to count how many total electrons we now have in this diagram, because we're trying to make sure that we get to 26. So Br has 2, 4, 6, 8. It's good. 10, 12, 14, 16, 18, 20, 22, 24, 26. It matches the total number of valence electrons that we're supposed to have, so that structure is correct. Moving on to our second one. Again, is it ionic or is it covalent? So this is a nonmetal. Hydrogen is a nonmetal. So 2 nonmetals again create a covalent compound. Again, decide your central atom. Hint here, hydrogens never can be your central atom because hydrogen only has 1 valence electron, therefore it can only form 1 bond. So it has to be on the ends. So that means my nitrogen is going to be in the middle with my hydrogens on each end, because covalent bonds are all about equal sharing. Let's determine the number of valence electrons total. So we have 2 nitrogens, and each nitrogen has 5 valence electrons. 2 hydrogens, and each one has 1. So we have 10 plus 2 is 12 valence electrons total. So again, go ahead and single bond everybody. Then we want to complete the octet. Hydrogen only has 1 electron to start with, so it can only gain 1 more. So hydrogen is happy already. We have to focus on the nitrogens. The first nitrogen has 2, 4, because remember each bond is 2, 5, 6, 7, 8. The second nitrogen has 2, 4 from the bonds, 5, 6, 7, 8. Everyone's happy. Now let's go in and let's count the number of valence electrons we have, because again we're trying to get to that magic 12 right there. So each bond or each line is 2, so 2, 4, 6. and then count the individual valence electrons. 8, 10, 12, 14. 14 is too many. When we have too many, because we want 12, we need to add an extra bond somewhere. So we're going to create a double bond. And in order to create a double bond, we can't do it between hydrogen and nitrogen, because remember, hydrogen can only form one bond, so it's going to be between these two nitrogens here. Now the trick is, when you add a bond, you must erase 4 valence electrons. You're going to erase from 2 from each atom that you connected. So I'm going to erase 2 from this nitrogen and 2 from the second nitrogen. Now I'm going to go back and I'm going to count my valence electrons. 2 in each line, so 2, 4, 6, 8, and then 10, 12. That is the correct number of valence electrons, so that is my correct structure. Moving on to our next one. We're going to, again, decide if it's ionic or covalent. Sodium is a metal. Chlorine is a nonmetal. So when we have a metal and a nonmetal bound together, we form what's called an ionic bond. Now, ionic bonds look a little different because we're not sharing electrons anymore. So since we're not sharing, we're actually transferring electrons. So our structure is going to look differently. So this time we're going to start out by drawing each individual Lewis dot structure for each atom. So sodium, and then we're going to add it to chlorine. Sodium has 1 valence electron, while chlorine has 7. Alright. Now we must decide which element is going to give electrons and which one's going to take. So the one that's going to give is always going to be the metal. The metal always gives to the nonmetal. It's the one that has the least amount of valence electrons to start with. So it's easier to move 1 than it would be to move 7. So I'm going to move 1 valence electron over here to chlorine, and we're going to form my ionic compound. Now, in chemistry, we have to denote that this chlorine has more electrons. So in order to tell me that it has more electrons, you're going to put brackets around it. And then you're going to tell me how many electrons it has. It has 1 extra electron, and electrons are negatively charged, so the chlorine has a negative charge. Sodium, on the other hand, since it lost a negative charge, it became more positive. So it's a positive charge. And there's our structure for sodium chloride. Here's another one for you. We have calcium. Calcium is a metal. Iodine is a nonmetal. So again, a metal and a nonmetal are going to create our ionic bond. Again, start with the individual atoms. So chlorine, iodine, and iodine. Not chlorine, calcium, sorry. Calcium has 2 valence electrons, so 1, 2. Iodine has 7. Yeah. Again, determine who is going to give and who's going to take. The metal always gives. So calcium is going to give its valence electron to iodine. And we're going to create a new structure. So you may see 2 different structures. I'll show them both to you. So the first one looks kind of similar to covalent in the fact that calcium is the one that we have the least amount of, so it's going to go in the center. And then I'm going to draw my electrons. Again, you have to denote the fact that iodine has extra electrons by putting a bracket around it. And iodine has 1 extra electron, so it's a negative. But this time, if you're looking at calcium, calcium lost 2 electrons. So now it's a positive charge, but it is a 2 plus because it lost 2. Moving on to our next one. Go ahead and put box around carbon. Carbon is a non-metal. Oxygen is a non-metal. So 2 non-metals create a covalent compound. In covalent compounds, we're sharing electrons, so it's going to look different than that ionic one that we were just working on. So again, we're going to go ahead and decide which one's our central atom. We have 1 carbon and 2 oxygens. So carbon's going to be our central atom with oxygens on either side. We then need to determine the total number of valence electrons. Carbon has 4 valence electrons. We have 2 oxygens, and each oxygen has 6 valence electrons. So 2 times 6 is 12 plus 4 is 16 valence electrons. And now we'll go ahead and we'll start doing our bonding. So we're going to bond oxygen and carbon with a single bond. And then we're going to go ahead and we're going to complete that octet. Oxygen currently has 2 electrons around it because there's 2 electrons per bond. So 3, 4, 5, 6, 7, 8. Carbon currently has 4, 5, 6, 7, 8. The other oxygen has 2. So we're going to add the 8. Now we're going to go back and we're going to count the total number of valence electrons we have. So each bond is 2. So we have 2, 4, then 6, 8, 10, 12, 14, 16, 18, 20. We want 16. So we have too many. When we have too many, again, we are going to create a double bond somewhere. It doesn't matter which side you do it on because it's symmetrical. So there's my double bond. When you add a bond, you must erase 4 electrons, 1 from each atom. So 1 from this oxygen and 1 from carbon. Now we count. Each line again is 2, so we have 2, 4, 6, 8, 10, 12, 14, 16, 18. Now we have 18, but we want 16, so again we have too many. So we must create another bond. So we're going to create another bond between carbon and oxygen. But we're going to do it on the other side this time because we're all about being equal. We add a bond, we must erase 2 electrons. Now we count 2, 4, 6, 8 in our bonded pair, 10, 12, 14, 16. That is correct. That is our correct structure for carbon dioxide. Now I have one more to show you. It's kind of a special one. Again, we're going to decide if it's ionic or covalent. So nitrogen is a nonmetal and oxygen is a nonmetal, so I'm looking at a covalent compound. This is different though. This -1 means we have 1 extra electron. Okay? So we have 1 extra electron. So we have to take that into account and we're going to start drawing this structure. So again, which one goes in the middle? I have less nitrogen than oxygen, so we'll put him in the center. Determine the number of valence electrons. Nitrogen has 5 plus 2 times 6 because of the oxygen, then plus that 1 extra electron that we were talking about. So this structure now has 12 plus 5 is 17 plus 1 is 18 valence electrons. Go ahead, single bond everybody. Complete your octet. And then count. 2 in each bond, so we have 4, 6, 8, 10, 12, 14, 16, 18, 20. I have too many, so I'm going to create a double bond. It doesn't matter which side. We create the double bond, we have to erase 4, and then we count again. Each bond is 2, so 2, 4, 6, 8, 10, 12, 14, 16, 18. We have reached the number that we need, but we need to go ahead. We have that extra electron, right? And to denote the extra electron, we must use those brackets. And we must put a charge. Since it's 1 extra electron, it's 1 negative sign. And that's how we draw Lewis dot structures for different compounds.